Today, I'm going to present some primary results about the sensing forest fire property in Northeastern Asia and South China with the satellite microwave vegetation index EDVI. As we know, a number of factors impact forest fire, which include the vegetation, weather, human being activity, topography, and the fire itself, such as the fire interval and the fire severity. Among those factors, the weather condition and the vegetation water state play critical role on fire. They determine the fuel flammability and the combustion state. At large scale, many researchers, they usually use the weather-based index and the satellite visible and the infrared observation to assess forest fire. However, effect of vegetation water state on fire are insufficient to consider, and the visible and the infrared spectra are greatly impacted by weather condition, and they are difficult to obtain water content information for the deep canopy. In comparison, the microwave are less impacted by weather condition, and they can provide unique information of water content in deep canopy. However, as we know that up to date, there are very few researchers that applied the satellite microwave to study forest fire. Based on this, this study explored the link and the application of satellite microwave vegetation index to forest fire. Our study focused on the Eastern Asia, which include two areas like the Northeastern Asia and the South China. In this figure, the different colors indicate fire detection from MODIS in different months. We can see that forest fire are common in these two regions, and the fire emission contribute to the local air pollution. Over these two areas, we can see that the dominant land cover type are forest and cropland. The major data used in our study is the microwave vegetation index, EDVI. Microwave is sensitive to vegetation water content. When going through a canopy, attenuation of microwave radiation is generally less at the low frequency compared to that at the higher frequency. For example, the radiation signal at 19 gigahertz, they represent the microwave emission from a deep canopy, like here, from a deep canopy. However, the radiation signal at 37 gigahertz, they represent the microwave emission from a channel canopy layer. The difference between the two frequency is sensitive to vegetation water content. Based on this, we calculate the EDVI, use this function. And we use EDVI to represent the vegetation water content. And other data used in this study include the fire weather index from the Canadian Forest Fire Weather Index system, and the satellite fire observation, which include the fire detection, fire radiative power. And we also use the MODIS land cover type data. In this study, we use very simple approach in statistics to analyze the correlation of fire counts and the fire radiative power with EDVI. We compared the correlation to that with the fire weather index. Finally, we combined EDVI and the fire weather index together to build a model to estimate fire counts and the fire radiative power. This figure shows the spatial distribution of EDVI, fire counts, and fire radiative power. As we can see, from spring to summer, EDVI, the value of EDVI, here I show the increase from low value to high value. And this indicates that the forest become moisture. At the same time, we can see that the fire counts and the fire radiative power they decrease from high value to low value. We further classified the fire observation into dry and wet forest group. And this figure I show you is the PDF distribution of fire counts and fire radiative power in the two groups. The blue column here indicates the results from wet forest, and the red column here indicates the PDF distribution from the dry forest. We can see that the FC and the FRP in wet forest are more likely to have the smaller value, right? Like the PDF shows, the wet forest like have many observations with small value. Analyze further revealed that for the daily variation, FC and FRP are generally negative correlate with EDVI. Like the figure B, like the figure this two figure shows. The blue color shows the negative correlation coefficients here. And the Pearson correlation coefficients are usually between minus 0.1 to minus 0.6. And the correlation, we can see that are more significant over those areas with frequent forest fire, like here. For the monthly variation, the correlation between forest fire and the EDVI are more significant here, as you can see by the scatter plot here. The correlation are very stronger between forest fire counts and the fire radiative power. In Northeastern Asia, the correlation is about 0.6, and it increased to 0.8 in South China. Annual cycle, for the annual cycle of EDVI, it's also opposite to FC and the FRP, like I show you here by the two figures. And the year-by-year variation of the summer forest fire in Northeastern Asia and the winter fire in South China, as well as the annual fire in South China, we can see that they also opposite to EDVI. Like the blue line shows results of EDVI. To explore whether EDVI provide new information in explaining the variation of forest fire, we compared the correlation to that with fire weather index. This slide shows the results, shows the correlation coefficients. We can see that in Northeastern Asia, the forest fire shows higher correlation with the fire weather index. However, in South China, we can see the forest fire are more correlate with EDVI, and such results are present both at daily, monthly, and annually scale. We further explore the joint effects of EDVI and the FWI on forest fire. And in this figure, the red and the yellow data points, they indicate the observation of high value of FC and FRP. We can see that FC and FRP are strongly dependent on both EDVI and FWI. For example, the high value of FC and FRP mostly correspond to low value of EDVI and relative high value of FWI. Based on this, we further combined the EDVI and the FWI together to establish multivariate linear regression model to estimate FC and FRP. This scatter plot that shows the results of the observation against calculate file count and file radiative power. We can see that the estimation of FC and FRP are improved using the multivariate linear regression model based on EDVI and FWI, compared to the estimation using the linear model based on FWI alone. And the similar results are present in the Northeastern Asia. In conclusion, this study provides primary evidence of the usefulness of satellite microwave index on forest fire research, which could be very helpful for a better understanding of the instantaneous and the mid to long term effect of vegetation water state on fire property. Like this study, I conducted this study with Professor Ray, and this study was just accepted 2 days ago by the Journal of Photogrammetry and Remote Sensing. That's all. Thank you for your listen. I'm very pleasure to answer your question. Thanks.